common theme is this idea of an object that moves through a fluid efficiently. And you have on a boat, even before foiling, you have a hull that's equivalent to a fuselage. There's a streamlined body that has to have a certain volume. Its primary job is to hold the thing afloat. On an aircraft, it's obviously to contain a payload. And you're trying to get this thing to move through the water or the air or whatever fluid it is with the least amount of fuss. On a sailboat, you can think of it as an aircraft with one wing in the water and one wing in the air. You have on a keel boat, the keel is there to provide side force to resist to counter the side force of the rig, which is what's extracting energy from the wind. You're trying to create the most lift for the least drag. And on a racing yacht, you have a wide range of speeds that you have to account for, because you might be sailing in light wind or in strong wind. You're going upwind, you're going downwind, so your angles of attack are changing. Now, doing it in a racing environment is interesting because you're in a situation where your work is constantly being measured. You have a way to validate your theories. You have a yes-no answer. You'll come up with an idea, you'll pursue it, you'll make a judgment about whether it's worth incorporating it into a prototype. You'll go out, you'll test, you'll race, and you'll get an answer, and you'll know whether what you've done is an improvement or is not an improvement. Obviously, there are subtleties around that. There are different factors that combine, and you have to be able to extract the signal from the noise, where you might make a modification that in itself isn't any good, but it might interact with other things and give you an advantage or not. And having that constant feedback, that validation, having a way to go into an environment where there are other very smart people trying to do the same thing and beat you around the track, there's this constant improvement. There is this ethos of, it's not a job, it's not a thing that you're doing for the sake of it, it's a way to obtain a goal, to influence the world in a way that adds knowledge, that brings technology forward, that creates something new that's better than what was there before. And that's sort of what got me hooked on the racing. And again, I'm not necessarily the most athletic sailor, so I'm not out there actually sailing the boat as much, but I'm observing how it works and how people interact with it, and how it's behaving, and constantly trying to understand that. So you're interrogating the laws of physics. You're saying, how is this thing moving through the water? How is it interacting? How is the air going around these fittings? And you're also trying to make it lighter as you go along, and that's purely a matter of reducing mass. But in situations where you might have a rule that mandates the weight, which is the equivalent to an aircraft having a payload that it has to carry around, you're then trying to make the best of that weight, so to put it in the place that's most advantageous. So there is still an incentive to make certain parts as light as possible, and making them lighter for something that's stressed, because it's reacting forces that are necessary to generate the motion that it needs. You're trying to get materials that are able to withstand higher specific stresses, and that allows you to then make parts smaller and thinner, which gives you the possibility to reduce drag. And there's this constant feedback, and that brings us to the interaction between aerodynamics and structures, where a sail is a perfect example. You have a membrane that's designed to have a specific shape to deflect air in a particular way to give you a certain performance. And it's a thing that in a static situation is just a floppy tent, but it's predisposed in a certain way so that as it gets loaded up, it takes this shape. And you're trying to do this as efficiently as possible, so you need to know how the stresses are moving through it, how it's reacting, how it's deflecting, how it's twisting. And it's supported by mast, and the mast is also reacting to forces in a certain way. When you start getting into high-speed sailboats, you have hydrofoils, which are wings, but they're moving through a very dense fluid, so the forces are very concentrated. They might be supporting the whole weight of the boat on a tiny little area with a really thin cross-section that you're trying to get as thin as possible by using these really strong materials. And regardless of the strength, they're going to move. And you want to know that they move in the right way, that their movement gives you an advantage. We've had examples in the America's Cup where you have a quirky rule that measures the hulls in a certain way. A team that I was a part of was able to make a hull that when the runners, the ropes that support the mast were loaded up, the whole hull twisted ever so slightly and effectively became longer than what was measured, and that then became a thing and everyone was doing it. And we're talking about an 80-foot boat with 12 people on it, and the thing's just twisting, and it's doing it because we want it to do it. And the fact that we can achieve that as a team, we have the expertise to analyze this shape and how it's going to behave, and lay out our fibers and our structures and our fittings in a way that this thing will do that and give us that infinitesimal advantage of having that slight extra length that's not taken account of in the measurement process. The thing with sailing, obviously, is that it allows a faster iterative loop where the certification process obviously is not as onerous, so you have a bit more freedom to go and try things. You still obviously have to be careful with safety and making sure that things are going to hold together and not pushing the limits too much. But it does allow us to sort of accelerate that iterative process. And again, a competitive environment allows that, because if the premium is performance and winning, then that justifies this continuous search for ever so slight improvements here and there. But most of the time it's just little tiny gains again and again and again that accumulate.